All right, this is section 9.1. We did 9.2 before 9.1, but now we're bumping back to 9.1. This is geometric mean. Here we go. On the side, do you see this little white area right here? I'm going to have you draw a picture. Here we go. Draw two triangles for me that are similar triangles. I'm making them right triangles, okay? Draw two triangles over there in that little corner area that are similar triangles, one bigger than one smaller. Go.
Does it have to be 90?
What? I don't care. I don't care. Okay, Wyatt, if you're not going to pay attention, you're going to go to the office. You choose. Go. Okay. All right, these two triangles, here's what I want you to do. We're going to label these dimensions, and here's what I'm going to say. I'm going to say that this side right here is 13. Whatever.
Looks more like 12.
Sure. That side is 13. Okay? And I'm going to say this bottom side right here, this bottom side right here is, let's say, 7. Okay? Now, one other thing that I'm going to say is that this side right here is the same length as that one, right? They kind of look maybe the same. I don't know. Okay? But they have that going on, all right? We skipped over chapter 8, which in a nutshell was talking about similar triangles. And one of the things that we do is when we're solving for an unknown variable, but we have similar triangles, we can set up a what? Proportion. Knock it off. No more. Okay. If we set up a proportion, what will it look like?
Proportionate. 13.
Sure. 13 over x equals x over 7, right? We can do that. Okay? All right, in this case, most of the time when we're doing similar triangles, we only have one variable to solve, or like one spot a variable, right? But here we have two. It's the same. It's going to be fine, right? 13 times 7, like I cross multiply, right? What's 13 times 7?
21. I don't know.
91. Nice try. And what's x times x?
X squared.
X squared. Now how do I solve for what x is? Okay, please do not waste my tape.
I'm taping.
Okay, you're not. Yeah. Take the square root. What's the square root of 91?
I don't know. Is there scissors?
No.
9.54. Right here.
9.54. There it is. Okay. 9.54. Okay. What we just did was we found what's called the geometric mean for 13 and 7. Okay. They will say find the geometric mean of 13 and 7. Okay. Now, not the same thing as the regular mean. What?
Where are the stars that have the lights on?
I think you took them. They were right here.
No, I have the ones that are wrapped.
They're right there.
Oh, okay, over there. I don't know.
Why are we interrupting class?
I don't know.
Are you recording?
What the heck?
Okay, yes, I am. Okay, not the same thing as a regular mean. Shh. All right, 8th period. Listen. Regular mean. If I say find the regular mean, that's like finding the average. If I average 13 and 7 together, you add them together. What's the average of 13 and 7? 10, right? 13 plus 7 is 20 divided by 2. Not the same thing as geometric mean. The geometric mean of 13 and 7 is 9.54, right? Because you are doing 13 times 7 and then taking the square root. Got it? That is what geometric mean is, not regular mean. Get regular mean out of your brain. Okay? Geometric mean. All right. Now, here is why we do this. Go to example 1. Let's go to example 1. We're finding the geometric mean of 5 and 45. Go. Example 1. 8th period. Pay attention. Let's go. 5 and 45. Geometric mean. If I do regular mean, let's just do this. If I do regular mean of 5 and 45, you should be able to do that in your head. 25, right? Wyatt's got it figured out. 5 plus 45 is 50 divided by 2 is 25. That's the regular mean. But geometric mean. Geometric mean means you're doing like 5 over x equals x over 45. Something like that, right? Okay? This is example 1 on the next page. We're going. Keep up. Geometric mean. If I take 5 times 45, that is how much? 225 equals x squared, and I take the square root. So it is not, the regular mean is 25. The geometric mean is 15, okay? A little bit different. It's like setting up a proportion. Got it? Regular mean, geometric mean. Got it? Okay, all right. Example 2. This is why. Here we go. First and foremost, they will give you a diagram like this, and this is why we skipped this on Friday because I knew you weren't ready for it, but I hope you are today, because how many triangles are inside of this?
Three.
3.
No.
There are 3, okay? There is a small one, which is this guy right here. There is a medium one, and the whole thing is a large one, okay? Small, medium, large. All right, so here we go. What I want you to do when we pick these 3 triangles apart, listen. Shh. When we pick these 3 triangles apart, we're going to label them and put them in the same position, okay? 8th period, you have got to listen. Shush. You be quiet. I don't care. I'll sit here after. I have nothing going on after school. I'll sit here. I'll wait to start the lesson until the bell rings. That'd be awesome. Okay, small triangle. If I position him this direction, which vertex is over here in this corner?
Q.
No. There is no Q on the small one. The small one's this guy. S is right here, and the bottom one is R. Okay. The medium-sized one, I'll do a different color, is this guy right here. Okay? This guy's T, this guy's Q, this one is S. Perfect. Okay. The overall big one is in the position that he is down here, so SRQ. That's what he is, right? Got it? So, we have a small, we have a medium, we have a large. Okay, now they want us to write a congruent statement. Not a congruent statement, a similarity statement. Write that down. A similarity statement that has what is similar to what. Got it? So over here they go STR. The middle guy goes what? QTS in that order. The large one goes QSR. In that order, gotta go that way, right? Okay. Now, example 3, they want us to use that kind of idea to solve some things, okay? So here is where the work comes into play. You've got to write your triangles out. So this guy has 3 triangles again. Let's face them all the same direction. If this is the small one, and this one's the medium one, and this one's the large one, write these down. Small, medium, large. Small, medium, large. Put these down off to the corner. We're going to label. Write these down off in the corner. We're gonna use this thing to label. Okay, small triangle. This one right here in black. What is his short side, like this bottom side? 8. What's his tall side? Z. What's his slanted side, his hypotenuse side? X. There you go. Okay. The medium one is this guy right here. What is his short side? Z. Tall side? 25. Hypotenuse side? Y. Boys, are you writing this down? Yes. No, you're not.
Actually,
Don't lie to me. You are not. I literally can see you out of the corner of your eye chatting over there. The large triangle, this guy right here. What is his short side? This bottom side right here. X. What's his tall side? Y. What's his hypotenuse side? Nope. Nope.
Except I don't know what that is.
33, right? Okay? All right, now I'm going to scrap this triangle. I'm going to scrap him, and I'm only going to use these 3 to solve, right? Okay? And I'm going to do a bunch of proportions. You may not solve for X first. You might solve for Z first. I don't care. Okay? But we got to figure out what we're gonna solve, all right? All right. If I want to solve for X first, okay? There are 2 triangles that involve X. Which ones? Small and large. Okay, so I see X here and I see X here. If I use this X, which side do I have to use in the large triangle? 33. If I use this X, which piece do I have to use over here? 8. Okay, so I got to use that to set up my proportions. So what over what equals what over what? X over? It doesn't matter? Sure, X over 8 equals 33 over X. You could go X over 33 equals 8 over X, either one. It doesn't matter, right? Okay. This is finding the what?
No,
Geometric mean, right? Okay. 8 times 33, give me that.
264.
264 equals X squared. Take the square root.
16.2.
X equals 16.2. Cool. There you go. There's X. Okay. Next. Should we try to solve for Y next?
Sure.
Sure. Why not? Okay. All right. I see a Y here and a Y here, so we're not going to use the small one, yeah? Okay. All right. If I use Y and Y, what other two things do I have to use?
Y over 25.
25 and 33, right? Because we're using the tall side and the hypotenuse side, and the tall side and the hypotenuse side, right?
Y over
Okay.
25 is 33 over Y.
Sure. Y over 25 equals 33 over Y? Yeah? So he did Y over 25, 33 over Y, right? What's 25 times 33?
825.
825 equals Y squared? 28.7. Okay, there's that. That's Y. Next, last one, Z. Let me get erased here. Hold on.
Oh, I love writing 7.
Okay, Z's. Which two triangles involve Z?
Small and medium.
Small, medium. I have Z here, Z here. What other two parts do you need? 8 and 25. Do you see how we know that? Tall, short side, tall, short side. Okay, so proportion.
200 equals Z squared.
What over what?
X, Z over 8 and Z over 25.
Okay, so you did Z over 8 and 25 over Z. Okay, 8 times 25 is 200 equals Z squared. Take the square root. Z is 14.1. Perfect. Perfect. There you go. Okay. Do we see how this works? Geometric means, lots of them. All right. Is that it?
So don't make us do that.
All right, we'll skip him. Okay, page 511. Right? Is it 511?
Yeah.
4 and 6 and
Not me. I swear, Jeff changed it. I was like, not 10.
actually let's just do 2, 4, 6. Why not?
You're so mean, guys. Look at my pretty
Woo!
You dropped them.
8, 12, 14, and that's it. We'll just do those.
Can you grab my cap?
6 problems, yes. Okay? 2, 4, 6, 8, 12, 14.
How nice of you, Comey.
Okay, but I only gave you 6 problems, but 8, 12, 14. Hey, folks, hold on.
You have to draw the frame.
8, 12, 14. I will count it wrong if you just put an answer and you do not write out the 3 separate triangles. I only make you do that on 3 problems. There are 6 problems total. Do the dang work, right?
Could you hand me my cap?
Do it. You have 6 problems total. All right, goodbye.